Hi guys, this is problem number 9. This problem will be a little bit challenging. So let's take a look at this question. The height h, so height of a projectile is a function of the time t it is in the air. So obviously if you project something into the air, the height depends on the time, how long the time has elapsed, right? Now the height is measured in feet and t is measured in second, and the height is given by this function, so h of t. How do you derive this one? If you're interested in it, we actually derive this kind of function in calculus. So not going to be talking about this right now. So the first question is, what is the domain of the function? So let's take a look at this height, okay? So the domain, which means what are the values of the time? First of all, I'm going to rule out a field. For instance, I'm going to rule out this one because this is from negative infinity to infinity. Keep in mind, the time should not be negative, so it has to start with 0. So all other ones with 0. And then I also rule out this one because it's just open parenthesis. Time can be 0. That's the time. This is open parenthesis means 0 is excluded. However, 0 can be included because that's the moment the object is projected into the air. So I would say, hey, now we are left with these two, right? We are left with these two because of the bracket. Now, which one is the correct one? I have two ways to do that. One, I would like to type the function into the decimals, so negative 16x squared plus 96x. You don't want to use t, by the way. You just use x. When you graph the function, you kind of like look at this one. I would suggest you to zoom out to look at the whole function. So it looks like this, but it's not very descriptive because of the like x and y, they're scaled the same. I actually want to scale it differently. So how about I click on this one just to make it look nicer, and I use my x-axis, say from negative 5 to say 10, okay, to say 10, so that you can see it better. Do you see that it's much nicer? So now the x-axis is scaled differently than the y-axis, so you can do the setting and then look at that. What I would like to explain is, keep in mind that the horizontal is your t, the time. Time cannot be negative, even though the graph looks like the domain is negative infinity to infinity. In reality, we should ignore these parts because time cannot be negative. Now, so when time is 0, the height is 0. When time is elapsing, the height is getting higher, right? So at some point, the object reaches its highest height, so which is somewhere here, and then it starts to drop. Now, of course, at some time it hits the ground and then it stays. So therefore, the height won't be like going down forever. So therefore, this interval is actually the legitimate domain for the function, okay, in our context. So it looks like from 0 to 6 inclusive. Okay, so that's why that there. And now we talked about using the graph to find the domain. We also I just would like to mention that you can actually find the domain by doing this. So factor out the negative 16t. You're left with t minus 6, okay? And then, the object, when it is projected, it starts with height 0 and then goes up and then hits the ground, which means height 0 again. So when you set this to 0, you are solving those two moments, when it is projected into the air and when it is hitting the ground. So in this case, t equals 0, that's coming from right here. So this t equals 0, right? Or t minus 6 equals 0, this gives you t equals 6. Okay, that's why we get to this point. Okay, so now the second part is, what does the domain mean in the context of the problem? So please read through that. I'll let you make that decision.